The Java Persistence Query Language. The Java Persistence Query Language defines queries for entities in their persistent state. The query language allows you to write portable queries that work regardless of the underlying data store. The query language uses the abstract persistent schemas of entities, including their relationships, for its data model and defines operators and expressions based on this data model. The scope of a query spans the abstract schemas of related entities that are packaged in the same persistence unit. The query language uses an SQL-like syntax to select objects or values based on entity abstract schema types and relationships among them. This chapter relies on the material presented in earlier chapters. For conceptual information, see Chapter 32, Introduction to the Java Persistence API. For code examples, see Chapter 33, Running the Persistence Examples. The following topics are addressed here. Query language terminology, creating queries using the Java Persistence Query Language, simplified query language syntax, example queries, full query language syntax, query language terminology. The following list defines some of the terms referred to in this chapter. Abstract schema. The persistent schema abstraction persistent entities, their state, and their relationships over which queries operate. The query language translates queries over this persistent schema abstraction into queries that are executed over the database schema to which entities are mapped. Abstract schema type. The type to which the persistent property of an entity evaluates in the abstract schema. That is, each persistent field or property in an entity has a corresponding state field of the same type in the abstract schema. The abstract schema type of an entity is derived from the entity class and the metadata information provided by Java language annotations. Backus nor form BNF. A notation that describes the syntax of high-level languages. The syntax diagrams in this chapter are in BNF notation. Navigation. The traversal of relationships in a query language expression. The navigation operator is a period, path expression, an expression that navigates through entity's state or relationship field. State field. A persistent field of an entity. Relationship field. A persistent relationship field of an entity whose type is the abstract schema type of the related entity. Creating queries using the Java Persistence Query Language. The Entity Manager. Create query and entity manager. Create named query methods are used to query the data store by using Java Persistence Query Language queries. The create query method is used to create dynamic queries, which are queries defined directly within an application's business logic. Public list find with name string name return M. Create query select C from customer C where C. Name like. Cust name. Set parameter cust name, name. Set max results 10. Get result list. The create named query method is used to create static queries, or queries that are defined in metadata by using the JAVAX. Persistence. Named query annotation. The name element of named query specifies the name of the query that will be used with the create named query method. The query element of named query is the query. Named query name equal find all customers with name, query equals select C from customer C where C. Name like. Cust name. Here's an example of create named query, which uses the named query. Persistence context public entity manager M, customers equal M. Create named query find all customers with name. Set parameter cust name, Smith. Get result list. Name parameters in queries. Name parameters are query parameters that are prefixed with a colon. Name parameters in a query are bound to an argument by the following method. JAVAX. Persistence. Query. Set parameter string name, object value in the following example. The name argument to the find with name business method is bound to the cust name parameter in the query by calling query. Set parameter. Public list find with name string name return M. Create query select C from customer C where C. Name like. Cust name. Set parameter cust name, name. Get result list. Name parameters are case sensitive and may be used by both dynamic and static queries. Positional parameters in queries. You may use positional parameters instead of name parameters in queries. Positional parameters are prefixed with a question mark. Follow the numeric position of the parameter in the query. The query set parameter integer position object value method is used to set the parameter values. In the following example, the find with name business method is written to use input parameters. Public list find with name string name return M. Create query select C from customer C where C. Name like 1. Set parameter 1, name. Get result list. Input parameters are numbered starting from 1. Input parameters are case sensitive and may be used by both dynamic and static queries. Simplified query language syntax. This section briefly describes the syntax of the query language so that you can quickly move on to example queries. When you are ready to learn about the syntax in more detail, see full query language syntax. Select statements. A select query has 6 clauses. Select, from, where, group by, having, and order by. The select and from clauses are required, but the where, group by, having, and order by clauses are optional. Here is the high-level BNF syntax of a query language select query. QL statement. Equal select clause from clause where clause group by clause having clause order by clause. The select clause defines the types of the objects or values returned by the query. The from clause defines the scope of the query by declaring one or more identification variables, which can be referenced in the select and where clauses. An identification variable represents one of the following elements: the abstract schema name of an entity, an element of a collection relationship, an element of a single valued relationship, a member of a collection that is the multiple side of a one-to-many relationship. The where clause is a conditional expression that restricts the objects or values retrieved by the query. Although the clause is optional, most queries have a where clause. The group by clause groups query results according to a set of properties. The having clause is used with the group by clause to further restrict the query results according to a conditional expression. The order by clause sorts the objects or values returned by the query into a specified order. Update and delete statements. Update and delete statements provide bulk operations over sets of entities. These statements have the following syntax. Update statement. Equal update clause where clause delete statement. Equal delete clause where clause the update and delete clauses determine the type of the entities to be updated or deleted. The where clause may be used to restrict the scope of the update or delete operation. Example queries. The following queries are from the player entity of the roster application, which is documented in the roster application. Simple queries. If you are unfamiliar with the query language, these simple queries are a good place to start. A basic select query. Select P from player P. Data retrieved, all players. Description. The from clause declares an identification variable named P, omitting the optional keyword as. If the as keyword were included, the clause would be written as follows. From player ASP, the player element is the abstract schema name of the player entity. See also, identification variables. Eliminating duplicate values. Select distinct P from player P where P. Position equal 1. Data retrieved. The players with the position specified by the query's parameter. Description. The distinct keyword eliminates duplicate values. The where clause restricts the players retrieved by checking their position, a persistent field of the player entity. The one element denotes the input parameter of the query. See also, input parameters and the distinct keyword. Using name parameters. Select distinct P from player P where P. Position equal. Position NP. Name equal. Name. Data retrieved. The players having the specified positions and names. Description. The position and name elements are persistent fields of the player entity. The where clause compares the values of these fields with the name parameters of the query, set using the query set name parameter method. The query language denotes a named input parameter using a colon, followed by an identifier. The first input parameter is position, the second is name. Queries that navigate to related entities. In the query language, an expression can traverse or navigate to related entities. These expressions are the primary difference between the Java persistent query language and SQL. Queries navigates to related entities, whereas SQL joins tables, a simple query with relationships. Select distinct P from player P, Indiana P. Teams T. Data retrieved, all players who belong to a team. Description. The from clause declares two identification variables, P and T. The P variable represents the player entity, and the T variable represents the related team entity. The declaration for T references the previously declared P variable. The Indiana keyword signifies that teams is a collection of related entities. The P teams expression navigates from a player to its related team. The period in the P teams expression is the navigation operator. You may also use the join statement to write the same query. Select distinct P from player P, join P. Teams T. This query could also be written as select distinct P from player P where P team is not empty, navigating to single-valued relationship fields. Use the join clause statement to navigate to a single-valued relationship field. Select T from team T, join T. League L where L. Sport equals soccer, Oregon L. Sport equal football. In this example, the query will return all teams that are in either soccer or football leagues. Traversing relationships with an input parameter. Select distinct P from player P, Indiana P. Teams AST where T. City equal city. Data retrieved, the players whose teams belong to the specified city. Description. This query is similar to the previous example but adds an input parameter. The AS keyword in the from clause is optional. In the where clause, the period preceding the persistent variable city is a delimiter, not a navigation operator. Strictly speaking, expressions can navigate to relationship fields related entities but not to persistent fields. To access a persistent field, an expression uses the period as a delimiter. Expressions cannot navigate beyond or further qualify relationship fields that are collections. In the syntax of an expression, a collection-valued field is a terminal symbol. Because the teams field is a collection, the where clause cannot specify P, teams, city in a legal expression. See also, path expressions. Traversing multiple relationships. Select distinct P from player P, Indiana P. Teams T where T. League equal league. Data retrieved, the players who belong to the specified league. Description. The expressions in this query navigate over to relationships. The P teams expression navigates the player-team relationship, and the T league expression navigates the team-league relationship. In the other examples, the input parameters are string objects. In this example, the parameter is an object whose type is a league. This type matches the league relationship field in the comparison expression of the where clause. Navigating according to related fields. Select distinct P from player P, Indiana P. Teams T where T. League. Sport equal sport. Data retrieved, the players who participate in the specified sport. Description. The sport persistent field belongs to the league entity. To reach the sport field, the query must first navigate from the player entity to team P, teams, and then from team to the league entity T, league. Because it is not a collection, the league relationship field can be followed by the sport persistent field. Queries with other conditional expressions. Everywhere clause must specify a conditional expression, of which there are several kinds. In the previous examples, the conditional expressions are comparison expressions that test for equality. The following examples demonstrate some of the other kinds of conditional expressions. For descriptions of all conditional expressions, see where clause. The like expression. Select P from player P where P. Name like Mitch. Data retrieved, all players whose names begin with Mitch. Description: the like expression uses wildcard characters to search for strings that match the wildcard pattern. In this case, the query uses the like expression in the wildcard to find all players whose names begin with the string Mitch. For example, Michael and Michelle both match the wildcard pattern. See also, like expressions. The is null expression. Select T from team T where T league is null. Data retrieved. All teams not associated with the league. Description: the is null expression can be used to check whether a relationship has been set between two entities. In this case, the query checks whether the teams are associated with any leagues and returns the teams that do not have a league. See also, null comparison expressions and null values. The is empty expression. Select P from player P where P teams is empty. Data retrieved. All players who do not belong to a team. Description: the team's relationship field of the player entity is a collection. If a player does not belong to a team, the team's collection is empty, and the conditional expression is true. See also, empty collection comparison expressions. The between expression. Select distinct P from player P where P salary between lower salary and higher salary. Data retrieved. The players whose salaries fall within the range of the specified salaries. Description: this between expression has three arithmetic expressions. A persistent field P salary and the two input parameters lower salary and higher salary. The following expression is equivalent to the between expression. P salary equal lower salary and P salary equal higher salary. See also, between expressions, comparison operators. Select distinct P1 from player P1, player P2 where P1 salary, P2 salary and P2 name equal name. Data retrieved. All players whose salaries are higher than the salary of the player with the specified name. Description: the from clause declares two identification variables P1 and P2 of the same type player. Two identification variables are needed because the where clause compares the salary of one player P2 with that of the other player's P1. See also identification variables, bulk updates and deletes. The following examples show how to use the update and delete expressions in queries. Update and delete operate on multiple entities according to the condition or conditions set in the where clause. The where clause in update and delete queries follows the same rules as select queries. Update queries. Update player P set P status equal inactive where P last played. Inactive threshold date. Description: this query sets the status of a set of players to inactive if the player's last game was longer than the date specified in inactive threshold date. Delete queries. Delete from player P where P status equal inactive and P teams is empty. Description: this query deletes all inactive players who are not on a team. Full query language syntax. This section discusses the query language syntax, as defined in the Java Persistence API 2.0 specification available at http://jcp.org. N. JSR. Detail. It equal 317. Much of the following material paraphrases or directly quotes the specification. BNF symbols. Table 34-1 describes the BNF symbols used in this chapter. Table 34-1 BNF symbol summary. Symbol description. Equal the element to the left of the symbol is defined by the constructs on the right. The preceding construct may occur 0 or more times. The constructs within the braces are grouped together. The constructs within the brackets are optional. An exclusive or boldface a keyword. Although capitalized in the BNF diagram, keywords are not case-sensitive. Whitespace. A whitespace character can be a space, a horizontal tab, or a line feed. BNF grammar of the Java Persistence query language. Here is the entire BNF diagram for the query language. QL statement. Equal select statement, update statement, delete statement, select statement. Equal select clause from clause where clause group B clause having clause order B clause update statement. Equal update clause where clause delete statement. Equal delete clause where clause from clause. Equal from identification variable declaration collection member declaration identification variable declaration. Equal range variable declaration join fetch join range variable declaration. Equal abstract schema name as identification variable join. Equal join spec join association path expression as identification variable fetch join. Equal join spec fetch join association path expression. Association path expression. Equal collection value path expression single valued association path expression join spec. Equal left outer inner join association path expression. Equal join collection value path expression join single valued association path expression. Join collection value path expression. Equal identification variable. Collection valued association field join single valued association path expression. Equal identification variable. Single valued association field. Collection member declaration. Equal Indiana collection value path expression as identification variable single value path expression. Equal state field path expression single valued association path expression. State field path expression. Equal identification variable single valued association path expression. State field single valued association path expression. Equal identification variable single valued association field. Single valued association field. Collection value path expression. Equal identification variable single valued association field. Collection valued association field state field. Equal embedded class state field. Simple state field update clause. Equal update abstract schema name. As identification variable set update item. Update item. Equal identification variable. State field single valued association field equal new value. Equal simple arithmetic expression string primary data time primary boolean primary nm primary simple entity expression null delete clause. Equal delete from abstract schema name as identification variable select clause. Equal select distinct select expression. Equal single value path expression aggregate expression identification variable object identification variable constructor expression. Equal new constructor name constructor item. Equal single value path expression aggregate expression. Equal average max min sum distinct state field path expression count distinct identification variable state field path expression. Single valued association path expression where clause. Equal where conditional expression group B clause. Equal group by group B item. Equal single value path expression having clause. Equal having conditional expression order B clause. Equal order by order B item. Equal state field path expression ask desk subquery. Equal simple select clause subquery from clause where clause group B clause having clause. Subquery from clause. Equal from subselect identification variable declaration subselect identification variable declaration. Subselect identification variable declaration. Equal identification variable declaration association path expression as identification variable collection member declaration simple select clause. Equal select distinct simple select expression. Equal single value path expression aggregate expression identification variable conditional expression. Equal conditional term conditional expression Oregon conditional term. Equal conditional factor conditional term and conditional factor. Equal NOT conditional primary. Equal simple condition expression conditional expression simple condition expression. Equal comparison expression between expression like expression in expression no comparison expression empty collection comparison expression collection member expression exists expression between expression. Equal arithmetic expression not between arithmetic expression and arithmetic expression, string expression not between string expression and string expression, data type expression not between data type expression and data type expression in expression. Equal state field path expression not Indiana in item subquery in item. Equal literal input parameter like expression. Equal string expression not like pattern value escape character no comparison expression. Equal single value path expression input parameter is not null. Empty collection comparison expression. Equal collection value path expression is not empty collection member expression. Equal entity expression not member of collection value path expression exists expression. Equal not exists subquery. All or any expression. Equal all any some subquery comparison expression. Equal string expression comparison operator string expression all or any expression Boolean expression equal. Boolean expression all or any expression enum expression equal. Enum expression all or any expression data type expression comparison operator data type expression all or any expression entity expression equal. Entity expression all or any expression arithmetic expression comparison operator arithmetic expression all or any expression comparison operator. Equal arithmetic expression. Equal simple arithmetic expression subquery. Simple arithmetic expression. Equal arithmetic term simple arithmetic expression plus arithmetic term. Equal arithmetic factor arithmetic term. Arithmetic factor. Equal plus arithmetic primary. Equal state field path expression numeric literal simple arithmetic expression input parameter functions returning numerics aggregate expression string expression. Equal string primary subquery. String primary. Equal state field path expression string literal input parameter functions returning strings aggregate expression data type expression. Equal data type primary subquery data type primary. Equal state field path expression input parameter functions returning data type aggregate expression Boolean expression. Equal Boolean primary subquery Boolean primary. Equal state field path expression Boolean literal input parameter enum expression. Equal enum primary subquery enum primary. Equal state field path expression enum literal input parameter entity expression. Equal single valued association path expression simple entity expression. Equal identification variable input parameter functions returning numerics. Equal length string primary locate string primary. Simple arithmetic expression ABS simple arithmetic expression SQRT simple arithmetic expression MOD simple arithmetic expression. Simple arithmetic expression size collection value path expression functions returning data time. Equal current date current timestamp. Functions returning strings. Equal concat string primary substring string primary. Simple arithmetic expression trim specification trim character from string primary lower string primary upper string primary trim specification. Equal leading trailing both. From clause. The from clause defines the domain of the query by declaring identification variables. Identifiers. An identifier is a sequence of one or more characters. The first character must be a valid first character letter, in an identifier of the Java programming language, hereafter in this chapter called simply Java. Each subsequent character in the sequence must be a valid non-first character letter, digit, in the Java identifier. For details, see the Java SE API documentation of the isJava identifier start and isJava identifier part methods of the character class. The question mark is a reserved character in the query language and cannot be used in an identifier. A query language identifier is case-sensitive, with two exceptions: keywords identification variables. An identifier cannot be the same as a query language keyword. Here is a list of query language keywords. abs all and any as ask average between bit length both by case char length character length class coalesce concat count current date current timestamp delete desk distinct else empty end entry escape exist false fetch from group having an index inner is join key leading left length like locate lower max member min mod new not no null if object of or order outer position select set size sum sq or t substring sum then trailing trim true type unknown update upper value and where. It is not recommended that you use an SQL keyword as an identifier, because the list of keywords may expand to include other reserved SQL words in the future. Identification variables. An identification variable is an identifier declared in the from clause. Although they can reference identification variables, the select and where clauses cannot declare them. All identification variables must be declared in the from clause. Because it is an identification variable has the same naming conventions and restrictions as an identifier, with the exception that an identification variable is case insensitive. For example, an identification variable cannot be the same as a query language keyword. See the preceding section for more naming rules. Also, within a given persistence unit, an identification variable name must not match the name of any entity or abstract schema. The from clause can contain multiple declarations, separated by commas. A declaration can reference another identification variable that has been previously declared to the left. In the following from clause, the variable t references the previously declared variable p. From player p, Indiana p. Teams AST. Even if it is not used in the where clause, an identification variable's declaration can affect the results of the query. For example, compare the next two queries. The following query returns all players, whether or not they belong to a team. Select P from player P in contrast, because it declares the T identification variable. The next query fetches all players who belong to a team. Select P from player P, Indiana P. Teams AST. The following query returns the same results as the preceding query, but the where clause makes it easier to read. Select P from player P where P. Teams is not empty. An identification variable always designates a reference to a single value whose type is that of the expression used in the declaration. There are two kinds of declarations: range variable and collection member. Range variable declarations. To declare an identification variable as an abstract schema type, you specify a range variable declaration. In other words, an identification variable can range over the abstract schema type of an entity. In the following example, an identification variable name P represents the abstract schema name player, from player P. A range variable declaration can include the optional AS operator. From player ASP to obtain objects, a query usually uses path expressions to navigate through the relationships. But for those objects that cannot be obtained by navigation, you can use a range variable declaration to designate a starting point, or route. If the query compares multiple values of the same abstract schema type, the from clause must declare multiple identification variables for the abstract schema. From player P1, player P2. For an example of such a query, see comparison operators, collection member declarations. In a one-to-many relationship, the multiple side consists of a collection of entities. An identification variable can represent a member of this collection. To access a collection member, the path expression in the variable's declaration navigates through the relationships in the abstract schema. For more information on path expressions, see path expressions. Because a path expression can be based on another path expression, the navigation can traverse several relationships. See traversing multiple relationships. A collection member declaration must include the Indiana operator but can omit the optional AS operator. In the following example, the entity represented by the abstract schema name player has a relationship field called teams. The identification variable called T represents a single member of the team's collection. From player P, Indiana P. TMST. Joins. The join operator is used to traverse over relationships between entities and is functionally similar to the Indiana operator. In the following example, the query joins over the relationship between customers and orders. Select C from customer C, join C. Orders O where C. Status equal 1 and O. Total price 10,000. The inner keyword is optional. Select C from customer C, inner join C. Orders O where C. Status equal 1 and O. Total price 10,000. These examples are equivalent to the following query, which uses the Indiana operator. Select C from customer C, Indiana C. Orders O where C. Status equal 1 and O. Total price 10,000. You can also join a single valued relationship. Select T from team T, join T. League L where L. Sport equal sport. A left join or left outer join retrieves a set of entities where matching values in the join condition may be absent. The outer keyword is optional. Select C. Name O. Total price from order O, left join O. Customer C. A fetch join is a join operation that returns associated entities as a side effect of running the query. In the following example, the query returns a set of departments and, as a side effect, the associated employees of the departments, even though the employees were not explicitly retrieved by the select clause. Select D from department D, left join fetch D. Employees where D. Det-no equal 1 path expressions. Path expressions are important constructs in the syntax of the query language, for several reasons. First, path expressions define navigation paths through the relationships in the abstract schema. These path definitions affect both the scope and the results of a query. Second, path expressions can appear in any of the main clauses of a query: select, delete, having, update, where, from, group by, order by. Finally, although much of the query language is a subset of SQL, path expressions are extensions not found in SQL. Examples of path expressions. Here, the where clause contains a single-valued path expression. The P is an identification variable, and salary is a persistent field of player. Select distinct P from player P where P. Salary between. Lower salary and higher salary. Here, the where clause also contains a single-valued path expression. T is an identification variable, league is a single-valued relationship field, and sport is a persistent field of league. Select distinct P from player P, Indiana P. Teams T where T. League. Sport equal sport. Here, the where clause contains a collection-valued path expression. P is an identification variable, and teams designates a collection-valued relationship field. Select distinct P from player P where P. Teams is empty. Expression types. The type of a path expression is the type of the object represented by the ending element, which can be one of the following: persistent field, single-valued relationship field, collection-valued relationship field. For example, the type of the expression P. Salary is double because the terminating persistent field salary is a double. In the expression P. Teams, the terminating element is a collection-valued relationship field teams. This expression's type is a collection of the abstract schema type name team. Because team is the abstract schema name for the team entity, this type maps to the entity. For more information on the type mapping of abstract schemas, see return types. Navigation. A path expression enables the query to navigate to related entities. The terminating elements of an expression determine whether navigation is allowed. If an expression contains a single-valued relationship field, the navigation can continue to an object that is related to the field. However, an expression cannot navigate beyond a persistent field or a collection-valued relationship field. For example, the expression P. Teams. League. Sport is illegal because teams is a collection-valued relationship field. To reach the sport field, the from clause could define an identification variable named T for the teams field. From player ASP, Indiana P. Teams T where T. League. Sport equals soccer. Where clause. The where clause specifies a conditional expression that limits the values returned by the query. The query returns all corresponding values in the data store for which the conditional expression is true. Although usually specified, the where clause is optional. If the where clause is omitted, the query returns all values. The high-level syntax for the where clause follows: where clause equal where conditional expression literals. There are 4 kinds of literals: string, numeric, boolean, and enum. String literals. A string literal is enclosed in single quotes. If a string literal contains a single quote, you indicate the quote by using 2 single quotes. S. Like a Java string, a string literal in the query language uses the Unicode character encoding. Numeric literals. There are 2 types of numeric literals: exact and approximate. An exact numeric literal is a numeric value without a decimal point, such as 65, minus 233, and plus 12. Using the Java integer syntax, exact numeric literals support numbers in the range of a Java long. An approximate numeric literal is a numeric value in scientific notation, such as 57, minus 85, 7, and plus 2, 1. Using the syntax of the Java floating point literal, approximate numeric literals support numbers in the range of a Java double. Boolean literals. A Boolean literal is either true or false. These keywords are not case sensitive. Enum literals. The Java persistence query language supports the use of enum literals using the Java enum literal syntax. The enum class name must be specified as a fully qualified class name. Select E from employee E where E. Status equal com. Zis. Employee status. Full-time. Input parameters. An input parameter can be either a name parameter or a positional parameter. A named input parameter is designated by a colon, followed by a string. For example, name. A positional input parameter is designated by a question mark, followed by an integer. For example, the first input parameter is 1, the second is 2, and so forth. The following rules apply to input parameters. They can be used only in a where or having clause. Positional parameters must be numbered, starting with the integer 1. Name parameters and positional parameters may not be mixed in a single query. Name parameters are case-sensitive, conditional expressions. A where clause consists of a conditional expression, which is evaluated from left to right within a precedence level. You can change the order of evaluation by using parentheses. Operators and their precedence. Table 34-2 lists the query language operators in order of decreasing precedence. Table 34-2 query language order precedence type precedence order navigation. A period arithmetic. Plus unary. Multiplication and division plus addition and subtraction comparison equal. 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 Not equal, not between, not like, not and is, not null is, not empty, not member of logical, not and or. Between expressions. A between expression determines whether an arithmetic expression falls within a range of values. These 2 expressions are equivalent. P. Age between 15 and 19 P. Age. Equal 15 and P. Age. Equal 19. The following 2 expressions also are equivalent. P. Age not between 15 and 19 P. Age. 15 Oregon P. Age. 19. If an arithmetic expression has a null value, the value of the between expression is unknown. In expressions, an Indiana expression determines whether a string belongs to a set of string literals or whether a number belongs to a set of number values. The path expression must have a string or numeric value. If the path expression has a null value, the value of the Indiana expression is unknown. In the following example, the expression is true if the country is UK, but false if the country is Peru. O. Country in us, France. You may also use input parameters. O. Country in us, France. Country. Like expressions. A like expression determines whether a wildcard pattern matches a string. The path expression must have a string or numeric value. If this value is null, the value of the like expression is unknown. The pattern value is a string literal that can contain wildcard characters. The underscore wildcard character represents any single character. The %wildcard character represents 0 or more characters. The escape clause specifies an escape character for the wildcard characters in the pattern value. Table 34-3 shows some sample like expressions. Table 34-3 like expression examples: expression true-false address. Phone like 12. 3123 12993 1234 our sentence. Word like I'll say lose award. Underscored like. Escape semicolon food bar address. Phone ID like 12. 312 34 123 12993 null comparison expressions. A null comparison expression tests whether a single value path expression or an input parameter has a null value. Usually, the null comparison expression is used to test whether a single valued relationship has been set. Select T from team T where T league is null. This query selects all teams where the league relationship is not set. Note that the following query is not equivalent. Select T from team T where T league equal null. The comparison with null using the equals operator equal always returns an unknown value, even if the relationship is not set. The second query will always return an empty result. Empty collection comparison expressions. The is not empty comparison expression tests whether a collection value path expression has no elements. In other words, it tests whether a collection valued relationship has been set. If the collection value path expression is null, the empty collection comparison expression has a null value. Here is an example that finds all orders that do not have any line items. Select O from order O where O line items is empty collection member expressions. The not member of collection member expression determines whether a value is a member of a collection. The value and the collection members must have the same type. If either the collection value or single value path expression is unknown, the collection member expression is unknown. If the collection value path expression designates an empty collection, the collection member expression is false. The OF keyword is optional. The following example tests whether a line item is part of an order. Select O from order O where line item member of O line items. Subqueries. Subqueries may be used in the where or having clause of a query. Subqueries must be surrounded by parentheses. The following example finds all customers who have placed more than 10 orders. Select C from customer C where select count O from C. Orders O 10. Subqueries may contain exists, all, in any expressions. Exists expressions. The not exists expression is used with the subquery and is true only if the result of the subquery consists of one or more values and is false otherwise. The following example finds all employees whose spouses are also employees. Select distinct emp from employee emp where exists. Select spouse emp from employee spouse emp where spouse emp equal emp. Spouse. All in any expressions. The ALL expression is used with the subquery and is true if all the values returned by the subquery are true or if the subquery is empty. The any expression is used with the subquery and is true if some of the values returned by the subquery are true. An any expression is false if the subquery result is empty or if all the values returned are false. The sum keyword is synonymous with any. The ALL and any expressions are used with the equal, and comparison operators. The following example finds all employees whose salaries are higher than the salaries of the managers in the employees department. Select emp from employee emp where emp salary. All select emp salary from manager M where M department equal emp department. Functional expressions. The query language includes several string, arithmetic, and date time functions that may be used in the select, where, or having clause of a query. The functions are listed in Table 34-4, Table 34-5, and Table 34-6. In Table 34-4, the start and length arguments are of type int and designate positions in a string argument. The first position in a string is designated by 1. Table 34-4 string expressions function syntax return type concat string length string int locate string start int substring start length string trim leading trailing both char from string lower string upper string the concat function concatenates two strings into one string. The length function returns the length of a string in characters as an integer. The locate function returns the position of a given string within a string. This function returns the first position at which the string was found as an integer. The first argument is the string to be located. The second argument is the string to be searched. The optional third argument is an integer that represents the starting string position. By default, locate starts at the beginning of the string. The starting position of a string is 1. If the string cannot be located, locate returns 0. The substring function returns a string that is a substring of the first argument based on the starting position and length. The trim function trims the specified character from the beginning end or end of a string. If no character is specified, trim removes spaces or blanks from the string. If the optional leading specification is used, trim removes only the leading characters from the string. If the optional trailing specification is used, trim removes only the trailing characters from the string. The default is both, which removes the leading and trailing characters from the string. The lower and upper functions convert a string to lowercase or uppercase, respectively. In Table 34-5, the number argument can be an int, a float, or a double. Table 34-5 arithmetic expressions function syntax return type ABS number int, float, or double mod int sqrt double size collection int. The ABS function takes a numeric expression and returns a number of the same type as the argument. The mod function returns the remainder of the first argument divided by the second. The sqrt function returns the square root of a number. The size function returns an integer of the number of elements in the given collection. In Table 34-6, the date, time functions return the date, time, or timestamp on the database server. Table 34-6 date, time expressions function syntax return type current date Java. SQL, date current time Java. SQL, time current timestamp Java. SQL, timestamp case expressions. Case expressions change based on a condition, similar to the case keyword of the Java programming language. The case keyword indicates the start of a case expression, and the expression is terminated by the end keyword. The when and then keywords define individual conditions, and the else keyword defines the default condition should none of the other conditions be satisfied. The following query selects the name of a person and a conditional string, depending on the subtype of the person entity. If the subtype is student, the string kid is returned. If the subtype is guardian or staff, the string adult is returned. If the entity is some other subtype of person, the string unknown is returned. Select P. Name case type P when student then kid when guardian then adult when staff then adult else unknown and from person P. The following query sets a discount for various types of customers. Gold level customers get a 20. Discount, silver level customers get a 15. Discount, bronze level customers get a 10. Discount, and everyone else gets a 5. Discount, update customer C sets C. Discount equal case C. Level when gold then 20 when silver then 15 when bronze then 10 else 5 and null values. If the target of a reference is not in the persistent store, the target is null. For conditional expressions containing null, the query language uses the semantics defined by SQL 92. Briefly, these semantics are as follows. If a comparison or arithmetic operation has an unknown value, it yields a null value. Two null values are not equal. Comparing two null values yields an unknown value. The is null test converts a null persistent field or a single-valued relationship field to true. The is not null test converts them to false. Boolean operators and conditional tests use the three-valued logic defined by Table 34-7 and Table 34-8. In these tables, T stands for true, F for false, and U for unknown. Table 34-7 and operator logic and TFU TTFU FFFFU UFU. Table 34-8 Oregon operator logic or TFU TTTTF TFU UTUU. Equality semantics. In the query language, only values of the same type can be compared. However, this rule has one exception: exact and approximate numeric values can be compared. In such a comparison, the required type conversion adheres to the rules of Java numeric promotion. The query language treats compared values as if they were Java types and not as if they represented types in the underlying data store. For example, a persistent field that could be either an integer or a null must be designated as an integer object and not as an int primitive. This designation is required because a Java object can be null, but a primitive cannot. Two strings are equal only if they contain the same sequence of characters. Trailing blanks are significant. For example, the strings ABC and ABC are not equal. Two entities of the same abstract schema type are equal only if their primary keys have the same value. Table 34-9 shows the operator logic of a negation, and Table 34-10 shows the truth values of conditional tests. Table 34-9 NOT operator logic NOT value TFF-TU. Table 34-10 conditional test TFU expression is true, TFF expression is false, FTF expression is unknown, FFT select clause. The select clause defines the types of the objects or values returned by the query. Return types. The return type of the select clause is defined by the result types of the select expressions contained within it. If multiple expressions are used, the result of the query is an object, and the elements in the array correspond to the order of the expressions in the select clause and in type to the result types of each expression. A select clause cannot specify a collection-valued expression. For example, the select clause P. Teams is invalid because teams is a collection. However, the clause in the following query is valid because the T is a single element of the team's collection. Select T from player P, Indiana P. Teams T. The following query is an example of a query with multiple expressions in the select clause. Select C. Name, C. Country. Name from customer C where C. Last name equal cost and C. First name equal Roxanne. This query returns a list of object elements. The first array element is a string denoting the customer name, and the second array element is a string denoting the name of the customer's country. The result of a query may be the result of an aggregate function, listed in Table 34-11. Table 34-11 aggregate functions in select statements name return type description average double returns the mean average of the fields count long returns the total number of results max the type of the field returns the highest value in the result set min. The type of the field returns the lowest value in the result set sum long for integral fields double for floating point fields big integer for big integer fields big decimal for big decimal fields returns the sum of all the values in the result set. For select method queries with an aggregate function, average, count, max, min, or sum in the select clause, the following rules apply. The average, max, min, and sum functions return null if there are no values to which the function can be applied. The count function returns 0 if there are no values to which the function can be applied. The following example returns the average order quantity. Select average O. Quantity from order O. The following example returns the total cost of the items ordered by Roxanne costs. Select sum L. Price from order O join O. Line items L join O. Customer C where C. Last name equal cost and C. First name equal Roxanne. The following example returns the total number of orders. Select count O from order O. The following example returns the total number of items that have prices in Helen Condense's order. Select count L. Price from order O join O. Line items L join O. Customer C where C. Last name equal and condenser and C. First name equal how. The distinct keyword. The distinct keyword eliminates duplicate return values. If a query returns a Java util collection, which allows duplicates, you must specify the distinct keyword to eliminate duplicates. Constructor expressions. Constructor expressions allow you to return Java instances that store a query result element instead of an object. The following query creates a customer detail instance per customer matching the where clause. A customer detail stores the customer name and customer's country name. So the query returns a list of customer detail instances. Select new ziz. Customer detail C. Name C. Country. Name from customer C where C. Last name equal cost and C. First name equal Roxanne. Order by clause. As its name suggests, the order by clause orders the values or objects returned by the query. If the order by clause contains multiple elements, the left to right sequence of the elements determines the high to low precedence. The ASC keyword specifies ascending order, the default, and the desc keyword indicates descending order. When using the order by clause, the select clause must return an orderable set of objects or values. You cannot order the values or objects for values or objects not returned by the select clause. For example, the following query is valid because the order by clause uses the objects returned by the select clause. Select O from customer C join C. Orders O join C. Address where A. State equal count order by O. Quantity O. Total cost. The following example is not valid because the order by clause uses a value not returned by the select clause. Select P. Product name from order O, Indiana O. Line items L join O. Customer C where C. Last name equal Fennel and C. First name equal Robert order by O. Quantity group by and having clauses. The group by clause allows you to group values according to a set of properties. The following query groups the customers by their country and returns the number of customers per country. Select C. Country, count C from customer C group by C. Country. The having clause is used with the group by clause to further restrict the returned result of a query. The following query groups orders by the status of their customer and returns the customer status plus the average total price for all orders where the corresponding customers has the same status. In addition, it considers only customers with status 1, 2, or 3, so orders of other customers are not taken into account. Select C. Status, average O. Total price from order O join O. Customer C group by C. Status having C. Status in 1, 2, 3.